Today we're going to take a look at the real number system, just to give you a reference point. And some of these numbers we're going to be dealing with very quickly, others of them not until much later in the semester. So this is what your sheet of paper that I passed out looks like so far, right? Yes. Lots of boxes, all blank, nothing in them. So we're going to start with the tiniest little box in the middle. And in that tiny little box in the middle, you're going to write natural numbers. So when you first learn numbers as a child, what's the first number you start counting with when somebody says, count to 100? 1. Those are the natural numbers. So when we teach children to count, we start with the number 1, 2, 3, and we keep going. Natural numbers. So that's pre-K, kindergarten, first grade, kind of where we live. But somewhere along the way, we start thinking about the concept of subtraction. When we start thinking about subtraction, there's a new number we need immediately, which is the number what? 0, right? There's no 0 that I just listed, and it's an awfully important number. So once we include the number 0, we're working in what's called the whole number system. So it includes 1, 2, 3, and so forth. That's why the box for natural numbers is inside of the box for whole numbers. But it also includes the number 0. That's pretty much all the numbers we need until we get to somewhere around 5th grade. And then in 5th grade, somebody does something screwy with your brain and they say, okay, but what if you did 5 minus 8? And you would probably have said at the first point, well, you can't do that, right? Because you'd been trained for so long that that's just not something you could do. And then some math teacher says, but you can, yeah? And they introduce what kind of numbers? Negatives. And those are integers. So our integer number system, again, includes everything we've already written down so far, but it also includes the negatives of that. So just like I talked about with whole numbers, it includes everything that we've already written. It includes the 0, it includes 1 through infinity, it includes all that, but it also includes the negatives of that. So you'll often see it written like this, where you start out with a dot, 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 and then you include the negatives, and I'll just include these, up until 0, and then you keep going to say, and I can include, of course, all the positives that I've already learned, and I keep going. Those are integers. So we had natural numbers, whole numbers, integers, and then sometimes even before you encounter the negatives, you encounter another type of number that's not on this list. So can somebody give me something you're not seeing on my list so far? What's a type of number you're not seeing? Rational. Can you give me an example of a rational number? Okay, all the numbers that are already listed are in fact rational numbers. I'll explain why in a minute. Can somebody give me an example of a number that's not on my screen? Pi. Okay, pi is going to go over here. We'll put it in since you mentioned it. I is complex, so it's like out here. Oh, poor little guy. We'll get back to him at another point in college algebra. What else are you not seeing? Decimals. Okay, decimals and fractions are also rational numbers. So this box over here is rational numbers. Again, it includes everything that's already been listed before, but it includes things like decimals. So I'm going to write some examples down because this one I can't do dot, dot, dots with, okay? So it includes 4.2 and like negative 3.7. Okay, positives and negatives. But if it includes decimals, it should also then include fractions. You got it? So we've got like 5 over 6. We've got even 6 over 5. They don't have to be written in proper form. They can be improper. Okay, so what does it take for a number to be rational? Well, it just means that it can be written as a ratio. Ratio means like fraction, right, of 2 whole numbers. And see, you can do that with all these down here. So let me just take 3 as an example. How could I write 3 so that it is a ratio of 2 numbers? 3 over 1. And that's not even the only way. I could write it as 6 over 2 if I wanted to be super creative, right? Yeah, it could. So every number that can be written as a ratio of whole numbers or integers, actually, because it could be negatives, is considered a rational number. So what that tells you about pi is that pi cannot be written that way. So I know that probably somewhere along the way, somebody said something like pi is the same as 3.14. It's not. 3.14 is an approximation. And usually it's a good enough approximation for what we do to use it, but it's not 3.14, okay? Pi has infinitely many non-repeating decimals, goes on forever. Pi is an irrational number. It cannot be written as a ratio of integers. There are other irrational numbers. Any ideas? We don't use them as frequently at this stage. You may or may not have heard of this one. Has anybody seen the number e? And if you haven't, it's okay. E is a number, it's about 2.718. I know you've seen the next one. How about square root of 2? Right? That's not rational. You put it in your calculator, it gives you a decimal expansion that never ends and never repeats. Okay, so those are irrational numbers. So this is where we're going to start our thinking. We're specifically going to work in some of these different number systems as we look at the very beginning of our class together. And to do this, we're actually going to first start talking about number lines and how we do graphing. So a reminder to you is that when we are graphing on a number line, we will read it the same way we read English, from left to right. So what does that mean? Well, it means that we have negative numbers if we go far enough to the left. We have positive numbers if we go far enough to the right. And we have smaller numbers that go on the left of larger numbers on the right. Okay, smaller to larger. So if you're thinking over here, these are smaller and these are larger. All right, so when they give you a number, like this one is 2.3, you're welcome to make a mark at 2.3 on a number line. And then around the 2.5 or 2.3, we're going to give some reference points. So what do I mean by that? Well, if we're working in tenths, which is 2.3, then the next thing would be what? 2.4. That's what we would naturally write next. And then we would have 2.5. And we might even have 2.6, 2.7, 2.8, 2.9. And then after 2.9, what would come if we're counting by tenths? 3. Okay? I'm not going to be too cranky about how specific and how detailed and how many marks you have, but you need to give me some kind of reference point. All right? And we'll go back to 2 as well. So this is 2.2, 2.1, 2.0. So here's 2. So this is something akin to what it would look like. I don't have a very good example in my drawing because I wrote a little bit too big and now my spaces are a little bit funky. Hopefully yours are a little bit better than mine. All right, so I'm going to draw one, and I want you to draw it as well, and then you tell me if you can figure out what this number should be. So I'm going to give you some reference points. I feel like I should have made that a little bit bigger. Let me try that. I know it's far away in what you're looking at it, but can you count and figure out maybe what that red dot should be? That red dot is what I'm calling location A. What should that number be? How is it different than the problem I just did before? What did my hash marks in the problem before count by? Tenths. Yeah, the first example I did, they counted by tenths. What is this example counting by? Somebody knows and you're just not telling me. It's hundredths. This is counting by hundredths, and the reason you know is because this is the 2.2, and this is 2.3, and they're spaced apart. Yes?
2.26.
There you go. That's the right one. This is 2.26 because it is the 6th hash mark after 2.2. So it's 2.26. If we're working in this, maybe a reference point for money is easier for you to think about. 2.2 is the same as $2.20. 2.3 is the same as $2.30. This number would be $2.26. Okay? So we're going to be doing a little bit of graphing. We're also going to be taking a look in this section at inequalities. I know you've seen all these symbols before. Jot them down and we'll make sure that everybody can remember what they are. Just make a list, kind of like my screen already looks. And then I need a volunteer of someone who would like to write on the iPad. Who would like to write on the iPad? It's really easy. It's totally not intimidating, I promise. Do you want to do it? Oh, no? Come on. Somebody volunteer for me. I don't want to, like, force somebody to. It's really fun. You try it. Okay. So do you see how I can zoom in and zoom out?
Mm-hmm.
That allows you to write at a normal kind of size.
Okay.
All right, and here's the, I use this part of that because it's right easier. Okay, somebody help him out. This is audience participation time. What does the first symbol marked there mean?
Greater than?
Is it greater than or less than? Do you remember?
It's less than.
That one's less than.
Okay.
So write less than for us on there. Lots of ways to remember what this is or which one it is. My favorite is the fact that if you were to tilt the symbol down a little bit, up a little bit, I guess it would be up a little bit from its perspective, it looks a little bit like an L. It's at least opening the same direction of an L, right? L for less than.
Oh.
It's okay. Undo button right here. Oh, where is it? Here.
Okay.
Okay, underneath that on my screen. If the first one was less than, what's the second one? Greater than. You guys are awesome. That is greater than. We're going to skip the bottom one and go over to the side. Okay? You got it, 2 fingers and everything. Awesome.
Yeah.
Okay, over here, this one.
Less than or equal to.
Oh, it's got an equals underneath it. Very good. So that means less than or equal to. So as awkward as it could be, I could actually write a 3 on each side of that and it would be true. 3 is less than or equal to 3. It'd be weird. We don't usually think about it that way, but it would be true. Less than or equal to. And the one underneath it? Greater than or equal to. Now, in terms of your homework and such, I don't really think that you need the next one, but to not include it would be weird because it's one of the inequalities as well. These are the 4 inequalities that we've already talked about that you'll see used most frequently. But the reality is there is one more. What is this symbol? Not equal to.
Not equal to.
Not equal to. We're not going to see it used often, but that's what it is. Hang on a second.
Gotcha.
Not equal to. Okay, so one thing that you can remember is which symbol actually means less than, which symbol means greater than. Thank you so much for your help. I appreciate it.
No problem.
Okay, so we already talked about, like mnemonic device, like thinking this looks a little bit like an L, so it's less than. Another sort of way that you can remember the symbols is not necessarily in terms of what we call them, but in terms of how they operate. Whichever side is bigger, this symbol opens toward it. Right? You can think about my teachers back in the day talked about it being kind of like a Pac-Man. Kind of feel like Pac-Man might have dated me just there. But just for fun, in case you don't know what Pac-Man is, Pac-Man looks kind of like that. I've heard it talked about as an alligator mouth before. I don't care. Whatever picture you want. It wants to eat the more thing. Whatever thing is more, that's what it wants to eat. So if you take a look at this symbol right here, the 6.21, 6.13, which one is more? 6.21. So which symbol will it open, or which number will the symbol open towards? The 6.21. You could put this symbol here. What else could you put there? You could put greater than or equal to. You could put not equal to, except that it's not one of the options that it gives you in that block, so we're not going to put that. Okay. Here is what we are going to do. There's one more thing I want to talk about in this section. I've got 2 minutes, which is not enough time to actually talk about the next chunk. So here's what we're going to do. And I'm still recording so that you can go back and remind yourself what I just said in case you're not, remembering after you've done all your new classes today. I'm going to hand out to you the homework. You should be able to do all of the homework problems through the greater than or equal to stuff, okay? You should be done. When you get in your homework to something that's talking about radicals and square roots, just pause. Please don't complete it, because you may or may not be remembering it accurately, okay? Agreed? At the very least, it's been 3 months since you've done math, with probably 0 exceptions, okay? So you just may not be remembering it accurately, so just hold tight to the square root stuff. We'll finish that part next time. We probably will have time in class to finish that section, like on your homework part in class even, and still do the next section. We'll see, okay?
So
Right.
would this be page 1 in our book?
You're going to write page 2B underneath it, okay? So, and in your table of contents, in between pages 2 and 3, you can write 2B, real numbers, because that's the one left out. And you can write 2C, homework, because that's what's missing. So in the bottom corner, top corner, wherever it is you want to write it, this is page 2B. If you don't have your notebooks yet, you can tape this in, just cut off the edges until it fits. You can tape it when you come to class. I've got the tape if you don't have any, and you can do that next time. Sound good?
Yes, ma'am.
Awesome.